Okay, so let me start off by kind of go over some properties um, that we need to be able to apply. So we have expansion properties that will be good for natural log as well as for log expressions. So here are the properties here. If I have log or ln of AB, I can expand that into log of A plus log of B. If I have log of A over B, I can expand it into log of A as log of B. If I have log of A to the n, that exponent can come down in front and log of A. Right, these are not anything derivative related, calculus related. These are just properties that will allow for a condensed problem to be split up into smaller parts so that your derivative will be easier to find. Okay. Derivative rules. These are the 4 new ones that we are responsible for. So natural log. Natural log is log base E. And log base E has a nice and clean derivative rule. This is u prime over u. Log base A of u, this is log that's other than base E. So base A can be 2 or 3 or 6 or 8. That also is u prime over u, but with a little bit extra, a little bit of change of base conversion that needs to happen in front. So we still have u prime over u. Okay, looks like natural log, but then there's a little bit of conversion here, so it has 1 over natural log of A. Basically, it's doing the work of converting into base E and then u prime over u for the rest of the derivative rule. Derivative for e to the u is just, this is exponential function. Base E is just e to the u times u prime. A to the u, this is base A, so base A can be base 2, can be base 3, can be base 5. So anything that is not base E, we lump it together into one rule and we call it a to the u. Okay, and the derivative for a to the u is very similar to e to the u. It's the original function times exponent's derivative, so I'll put that down. We know that is part of it. But then there's also a conversion that has to happen, so that conversion looks like natural log of A. So it's just a number, coefficient that has to live in front of my derivative.
And sign. I've been like here. I would do like 6 tests actually. It's like reverse tuning. So
Your phone here. Yes, put it in the slide. Actually. Okay, so number one, this is a really messy natural log problem. We're going to take the time to expand first, so we can use quotient property to expand this out, and then we can take advantage of the natural log rule, okay, u prime over u. Okay. I can go ahead and kind of rewrite terms as I see it. This is a messy problem, but I can convert them each into rational exponents if I see a bunch of radicals. So this matches nicely with this form. Okay, log is just base e, so natural log is just log base e. So we can apply this a over b. My a is my numerator, my b is my denominator. I'm going to expand, but as I expand, this 2 is going to have to distribute through each of the terms. Okay, any questions so far? All right, so this exponent 3/4, we want to bring that down as well because this is part of power property. Again, this is not a derivative. It feels like power rule for derivatives, right? You bring that exponent down, but we don't do power rule for natural log. That's just for rational functions or rational expressions, or sorry, a variable raised to an exponent. So this 3/4 to come down, multiply that 3/4 by 2. So I'm still in my cleanup stage here. Okay, so now I can jump into my derivative rule. So my derivative rule for natural log is u prime over u. My u value is just basically whatever's inside my natural log expression. So basically everything inside the parentheses is my u value. Okay. And then anything in front is just going to hang out in front. So y prime equals, coefficient is going to stay. I can reduce this to be 6/4 or 3/2. If when I start applying my derivative rule for natural log, notice my natural log notation goes away. It's just u prime over u. Right? I don't attach natural log to my derivative. It's just u prime over u. We're just following what the rule says. So u prime. What's the derivative of my u value here? 3x becomes 2x to the 4th becomes 8x cubed. All over my denominator, u value. Okay, minus. Same thing here, u prime over u with the coefficient that's going to hang out in front. So u prime is 6x squared or 2x cubed. And not a whole lot that I can do. I can maybe put all this under one fraction, and I can do a little bit of reducing here. X is canceled out, 2 is canceled out, but I cannot cancel the 3 and 8 and 2 and the x cubed, right? That minus sign is preventing us from doing any of that. Um, 2's cancel out. One of the x's cancel out. I'm left with just 6/x. Any questions here? Okay, number 2. Y equals x cubed times e to the 5x squared plus 3x. We can't rely on one rule here. There, you see there's a multiplication in between the two terms, so we got to go through a product rule, right? X cubed can represent f. E to the 5 squared plus 3x is my g. I got to go through product rule. And once I'm inside and beginning product rule, I can take care of each derivative. So the first term is power rule, and the second term is my e to the u rule. So eventually I'm going to do this e to the u times u prime, but I'm going to start off understanding that my derivative is going to come within the context of product rule here. Okay, so f prime g plus f g prime. F prime will just be 3x squared. G function is just what I see in front of me. Back to f. And then g prime, I have to apply my derivative rule for e to the u. So I just follow what the rule says. The rule says e to the u times u prime. U prime is just my exponent's derivative. On my key, I took out a GCF, but this is fine if you leave your answer. Just maybe put things a little closer together here. Okay. Any questions with 2? Yeah. Yeah. Looking to see if you can do a little bit more, at least try to clean it up a little bit. Yeah. Okay, no questions to 2. It doesn't really matter. Yeah. All right, number 3. Right, so this is a log expression. We know this is not natural log anymore. This is log base 8. But before we jump into our derivative rule for log base a, want to see if we can get this cleaned up a little bit. Right, that radical can be converted into rational exponent. Bring that exponent down in front. So let's do some cleanup first. Okay, push that exponent down in front. Okay, so now I'm ready. Oh, yeah, that 1/2 came down, but it canceled out with the 2. So I'm left being able to now find my derivative. So I'm going to follow what the rule says, right? My a is 8. My u is that parentheses. So 1 over natural log of 8 times u prime over u. U prime, x becomes 1 minus e to the x. The derivative for e to the x is just e to the x times x's derivative, which is 1. So just function itself, basically. All over my original u value, which is the parentheses. Any questions with 3? And here's number 4. Okay, so again, we need to see that these are 2 separate terms. Got to go through product rule. Once we're inside product rule, we can handle each of their derivatives based off of what rule we need to apply. So e to the 3x is gonna, this is base 2 is an exponential function. This is gonna be following this a to the u rule. Log, what base is this here? 10, right? So we got to do the log base a rule. Okay, so we're applying these 2 rules here, f prime g plus f g prime. I'm gonna rewrite this just to show that base 10, and I want to also get that radical ready. Okay, f prime, so my derivative for a to the u, it's just natural log of a times a to the u times u prime, so natural log of 2 times the original function times the exponent's derivative. My g function. Back to my f function. Okay, so g prime. So log base 10's derivative is 1 over natural log of 10, because 10 is my a value, times u prime over u, so I need to find the derivative of this parentheses, put it up here, put the entire parentheses down here for this u value. Okay, so here's my derivative. I'm gonna do a little bit of cleanup here. The -2 and the x to the -1/2, I can push that down to the denominator, just to make it a little bit cleaner here. All this can merge together, so I'll put this all into one fraction here, and that minus will just carry over to over here. My key shows a little bit differently. I converted this to natural log, but this is fine. I think this is easier. Okay, number 5. Okay, so I'm gonna rewrite. I know I have to apply my expansion properties to get my log expression a little bit cleaned up. Both these terms, we can apply the rule for log base A. Coefficient stays. Log base 2 goes through a little bit of a conversion. Prime over U. Same thing here. Log base 2 goes through conversion. U prime over U. Minus. Okay, number 6 is an exponential function. This is a base raised to an exponent. This is a to the u. I'm gonna follow my a to the u rule, but my u is kind of messy. I can't expand this out, but I can rewrite it using rational exponents. So when I get to u prime, I can go through proper rule for this exponent expression. All right, so we'll step through our rule. Yes, question. Oh, sorry, to the 1/3. Is that what you guys get? Sorry, 1/3. Now, we can't bring this 1/3 down in front. There's no log property. We have to kind of leave it there, right? There's no natural log or log. This is stuck in this form. But we can still find the derivative. We just have to go through a little bit of a chain rule once we get to this upper portion. But let's see what the rule says. Take it step by step. We start off with natural log of a. Oh, that's 11, natural log of 11. Times the original function. I'm just going to copy this down here. Or this, either one's fine. Both the same. And then finally, it's asking for u prime. So u prime is do whatever step is necessary to take care of the full derivative of your exponent. But my exponent is a function within a function, so just this portion requires what? Requires its own chain rule. It's gonna be a little bit long here because we got to deal with this outside portion and the inside portion. So outside derivative is 1/3 parentheses to the negative 2/3. So all that's going to go here. And the parentheses outside. Right, so we bring down the 1/3, we subtract 1 from the exponent, we keep the inside intact. We've now taken care of the outside derivative portion, but we still got to take care of the inside. So the inside, we're going to take each derivative piece by piece, and they're all going to go in their own space. 4x becomes 4. 5x cubed becomes 10x squared. Then what happens with 3e squared? Is it 6e or is it 0? 0, right? We don't do power rule if that value, if that is not a variable. Right? E looks like a variable, but it's a number, right? So 3e squared, that's just some number, and the number will just go to 0, so it just goes away. I'll put a -0 to show that it goes away, but we can do that space. Okay, just some cleanup here. I'll just try to put all this under one fraction, and I'll put where the numerators belong and denominators belong. So numerator, 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 denominator, denominator. Okay, any questions? Right. I'll come around and see if you guys have any individual questions.
He did a little differently. It's just. It's more cute, you know, like. I'm here, I like, go, but yeah, you're here, like, after. I feel like this is pretty absurd. I love so. I was worried. This team, of course, that one. You can say that. Someone will be offended. Why were you checking it? Are you checking it? You decide today?
I don't know, I haven't talked to you guys.
You know, going back to the field and stuff like that. I'm generally home.
Are you looking at this for that? You're looking at
It's back at the end. It's like 5 months. They give like a little like. I like. I would like to see that's like 5 months. I looked at it. Start playing the piano. That tie. It ties into the side.
Okay.
Good.
Yeah. I don't know, I'll see I have the flu, so, like, last night, and then like in my bed, couldn't get out of my bed until last night, and then like, I woke up this morning, and I have to have a fever in like 24 hours, and they're like, yeah, I gotta study sign. Yeah, I'm not done with the question. It's stress. And I didn't know I didn't hear that. I took boat camp today. That's big problem is my.
I will be here tomorrow.
Thank you.
I'm just.
Oh, very close. Okay, the project I'm taking job. I don't even know what it is. She don't even know what it is. Like. I don't even know what that is. I wasn't there.
Like.
I don't know, like,
Like.
I don't even know what it is. I'm just gonna show you. Guys, I don't know. I'll say this, I was at your parents' house. I don't know what she wants me to do. But I'm sure she'll just say something. Yeah. Which is funny, cause I like got that email. It's like, girl, did you not realize I have to finish class in the past? Like, I haven't been at school for Thursday. Yeah, so I don't know.
Our understanding, does it matter if we leave it in writing? No, it doesn't matter.
It doesn't matter. Because on the key, you switch it backwards.
It did, yeah, I probably just.
Okay.
Went back.
All right, thank you.
The type on the one, on like number 5, the long one.
Yeah. But if I had to do this in my order right now, I don't think I would. But I don't want to.
If he was the exact same thing.
It was here for like David.
Something like a bracket.
Yeah.
Oh. That's such no, that was. I'm gonna explain, is there two that guys so quickly, like. That's all I'm going.
Yeah. Two and three canceled out.
Yeah, okay. You don't need AirPods.
Yeah. It's not that hard.
How many phones do you get? That makes me think you really I literally know.
The first day I like learned what this thing even was. It's not like I had no clue what this was.
No, but give me that one, only, give me that one, that one. I didn't-